So we're going to have a look at this review problem R8-6 from the 5th edition of the Hibbler's textbook, Strength of Materials. So basically the question is, we have a bolt here connected to the head of a compressor. It's under 800 pounds. They give you the diameter and they ask you some questions about the strain on that bolt. So reading the question, we have the head H, this right here, is connected to a cylinder of a compressor using 6 3/16 inch bolts, diameter steel bolts. If the clamping force in each bolt is 800 pounds, determine the normal strain in the bolts if sigma yield is equal to 40 ksi and the Young's modulus of the steel is 29 times 10 to the third ksi. What is the strain in each bolt when the nut is unscrewed so that the clamping force is released? So that's where the sigma yield term comes in. Okay, so let's start here. So this is problem R8-6. So review problem 8-6. So what do we know? We know the sigma yield is equal to 40 ksi. The Young's modulus of the steel in the bolt is equal to 29 times 10 to the third ksi. We know that the load on the head, or the force, is equal to 800 pounds. And we know the diameter of the bolt equals 3/16 inch, which equals 0.1875 inch. Okay, so I'm just going to start writing some equations down here. So we know that the normal stress is equal to Young's modulus times the strain, okay? We know that the normal stress, Hooke's law, or Young's modulus, is equal to the force over the area, okay? So we know this, we can solve for this, so then we can solve for this strain, if you think about it. So what is sigma, or the normal force, equal to? So it's equal to 800 pounds over pi, the diameter, 3/16, which is 0.1875 inches squared, and all that over 4, because this is the diameter. Okay, and just a segue for a second. So pi area is equal to pi r squared equals area. We talked about this the other day in class. If you put in d squared, it goes pi d squared, pi d over 2 squared, which equals pi d squared over 4, which is where this 4 comes from. So when we solve for this, we get the normal stress to be equal to 28.97 ksi, or thousands of pounds per square inch. Okay, so going back to Hooke's law for normal stress, we can say now that sigma is equal to the normal stress over the Young's modulus of the material. So we know that. We know this term up here. So then we can say 28.97 ksi over the Young's modulus of the steel, which is 29 times 10 to the third ksi. And this all equals 9.99 times 10 to the negative 4. So that's the strain on the bolt head when it's loaded. One of the questions were asked, if we go back here, if the clamping force is 800 pounds, determine the normal strain on the bolt. So we've answered that question. If sigma yield is equal to 40 ksi and the Young's modulus of steel is equal to 29 ksi, what is the strain on each bolt when the nut is unscrewed? So is there any strain that becomes permanent? So if you think about it, sigma yield is 40 ksi, our sigma applied is 29 ksi, right? So sigma, I'm going to call this applied, is less than sigma yield. So when the bolt is unloaded, There's no plastic strain, so the strain after unload equals 0.